Thanks, everybody. We've got a pretty interesting session today. We're going to talk about how Goldman Sachs applies security to secure container apps. But before we do that, we'll get into just a couple little background items. So I'm Gary. I'm one of the PMs mainly on the container runtimes for Google, joined by Xiaowen. She's going to talk about Cloud Run, and then Shivam's going to actually tell us about the cool stuff Goldman Sachs is up to. So let me ask a quick question just to see where everybody is. How many folks are actually running containers in production today? Fantastic. If you weren't running them in production or you're running them in dev, plan to do it in the next 6 to 12 months? Cool. Awesome. And then I guess a more important question, how many of you are using Cloud Run or GKE? I like this crowd already. So I won't go into too much detail here, but we're going to focus mostly on sort of Cloud Run and the serverless side, but really we have sort of two container platforms in Google Cloud. Now, I should caveat this with I love containers, so I'm obsessed with them, so I'm kind of like a fanboy for them, so I believe that they are kind of the current wave on where things are going to go. On the left-hand or right-hand side for you, GKE, clearly most of you know we started, Google founded kind of Kubernetes, contributed that out there. GKE is kind of our flagship managed Kubernetes service. A lot of the things that we focus on there are making it super simple to use. You may have seen the announcements from TK, and there's some other sessions today on how we're hardening GKE, making it better for the enterprise with GKE Enterprise. And we'll talk a little bit about some of the security stuff we have there. I don't want to say for simpler workloads, but for folks who just want to quickly getting started, up and running, get containers in production, we have Cloud Run, really our serverless container platform, right? You do not see the compute. It does a lot of magic for you. Xiaowen and Shivam will cover that as well. Now, most of you are using containers, but for those of you who aren't, there's a few fun facts. That, one of the reasons why I like containers is when containers are used properly, meaning, I guess I started this expression, do not treat containers like virtual machines. I think, way back when containers first came out with, way back when in containers have been around for a while, but when Docker, say, popularized containers in 2014, we had things like, hey, let's use Ubuntu and Debian, right? And all of a sudden, we had these big bloated container images, and you have the same vulnerabilities that you have at an OS level, right? So you really don't want to treat kind of containers as VMs. You want to treat containers as the minimal thing to package whatever dependencies you need for your application. And when you do that, it makes it pretty simple to patch these things, right? You have minimal dependencies in there. You can do the ones that are specific to your application, to your code, et cetera. The other thing, containers at runtime, technically immutable, right? Now, you can do bad things if you want, but technically, you sort of don't change them when they're sort of running. From a security perspective, it's pretty simple to configure things. I mean, we're using things like C groups and other things underneath the covers. If you look at how we configure it on Cloud Run, you'll see from a Kubernetes perspective, very simple to turn off things like privileged access, to set permissions on them. So it's much easier than if anybody actually had to go in and do security defaults for kind of a full operating system as well. And the other thing is it's just simpler, in my opinion, right, to go add how we can sort of isolate these things, right? If you start looking at running, I'm an old person, so I know when people went to running stuff on bare metal, and then you have VMs, and then people went to running an app per VM because you can't isolate your applications. Apps have different dependencies, et cetera. From a container perspective, they're already isolated, right, at a base level. We've implemented technologies. We use them in Cloud Run for actually isolating multiple containers from each other on the same host. Within GKE, we have something called GKE Sandbox, which is actually based on gvisor, an open source thing, which again gives us an enhanced isolation by basically intercepting all system calls, right? Preventing container breakouts. So again, they're just a great, simple way to package your applications, keep them isolated from each other, and kind of get going. That being said, I sometimes wonder, and you said I love containers, and then I show a slide that says, well, here's all the potential risks of deploying a kind of a container production. In the end, to some degree, this isn't different than any other sort of pipeline, right? You can have all these same threats no matter how you're sort of depending your applications. As you'll see, I think from a container perspective, it's a lot easier to sort of fix those, right? Clearly, you can have issues with source. I mean, that's obviously one of the greatest threats and vulnerabilities that are in there. Build systems can be compromised. Somebody can kind of inject something in there. We've seen some of that stuff with some of the hacks from hackers on some of the, I'm not picking them out, but on like Microsoft's distribution can be in there. Obviously at deploy time, you want to prevent rogue actors. You know, one thing about like a great example a long time ago, I used to work at IBM. Microsoft made it such that you could have .NET applications or COM applications talk to the mainframe at that time. The mainframe used to be super isolated. You had to know how to make SNA and write applications there. Now we expose it outside, right? There's additional threats and vulnerabilities that you need to think about. So it's simple to deploy containers, but you have to also put some controls in place, right, to keep people from just deploying rogue containers out there. And then finally, what are the things that we can do to sort of measure things at runtime, right? Can we look at, is it still the same container? What access, et cetera, is it making? Now, we'll cover a few of these in a few slides, but so as with everything, I think everything, you know, buzzword term, everything kind of shifts left. I'm not a huge fan of saying that we have to shift everything to developers. But I think as we look at things that sort of shift left, going back to the sort of prior slide, how can we put better controls and things in place like along this whole pipeline, right? Such that, and not necessarily a dev having to do everything, but as things go through this life cycle, how can we sort of deal with this stuff, right? So making sure trust is obviously key. At some point you have to trust something and attest to something, right? And make sure that that came through. And that's going to be sort of in your process. When you actually deploy something, how can you ensure that you deployed what you thought you built, right? And how do we make sure that can happen? And then finally, at runtime, how can we make checks to make sure that you haven't sort of violated all of that? And we'll get into details on some of those in the later slides. One thing that since I only have like 10 minutes, one thing that I wanted to sort of call out is, we'll talk about how you can do some of these things, but in the end, there's kind of an interesting technology that came out there. How many people have heard of, are familiar with all this secure supply chain, right? S-bombs, all these buzzword soup out there, right? But they all kind of make sense, right? How can I trace everything in its dependencies? How can I know where the vulnerabilities are? How can I trace something through the life cycle? So something like binary authorization, as you can see, we'll talk about how you can do things at every step, but how do you make sure that by the time you get to production, something has been through that pipeline and all those steps have been taken? So binary authorization is one of the kind of cool things for you there, right, to ensure that. So from our container runtime perspective, it's built into Cloud Run. You can turn it on in GKE. I think on GKE Autopilot, we're going to actually turn it on by default soon. And in this case, you can say, my container must have no vulnerabilities. It must have been built, for example, by Cloud Build. It must have been proved and signed by this key. And that's going to keep rogue actors from basically being able to deploy those things onto your runtimes. If we kind of put it all together, containers don't live in a world by themselves, especially in Google Cloud. I think the things, so I've been here about 2.5 years maybe. I think we've done a really nice job of actually trying to put together kind of this end-to-end system, which we'll talk about a few pieces, but obviously we can start from a code perspective. You've probably seen that we have things like secure open source now, right, where we're putting out packages for Python, Java, even Go, right, that you can have trusted and assured open source. Make sure you're pulling those in, and Node pulling those in only. Starting with secure base images, whether you use our secure base images or you use stuff from ChainGuard, for example, is a great company focused on that, building CV images that are sort of light and minimum weight, putting them into a registry, scanning them for vulnerabilities. We have a registry, all other registries have this stuff. And then, assuming you did all those kind of steps, you can package that all up together. That becomes your sort of S-bomb. You can attest that all that was done, sign it from a binary authorization perspective, have any audit controls, logging, et cetera, from your reporting perspective, and then deploy it. Now, it's not going to prevent everything, but in the end, you've kind of got this really secure end-to-end kind of pipeline. And the nice part here is because we had a container, we have the app, we have the OS dependencies, we have that, we can do it on kind of that per application basis rather than having to separate everything out, right? From here was my VM, hardened VM image, then here's my app code, then here's everything else. I can consider the container to be that unit of deployment holistic across that application. I think that concludes my part. So that's just some basics. We're happy to take questions afterwards on a lot of this stuff. We're going to talk a little bit specifically. Xiaowen's going to tell us about all the great things that Cloud Run's been doing.
All right, thanks, Gary. Hi, everyone. My name is Xiaowen. I am the lead product manager for serverless enterprise networking security. Really happy to be here this Wednesday, bright and early Wednesday morning. I hope everyone got a lot of good sleep or a lot of good coffee, and we're ready to talk more about security. Okay, so for the next few minutes, we're going to talk about a few design patterns, a couple of design patterns that are for some common use cases, and talk about how to secure them. So, oops, wrong slide. All right, so as Gary mentioned, I'll talk much more about Cloud Run. The design patterns that we're talking about are built around Cloud Run. Now, as Gary mentioned, Cloud Run is Google's fully managed container runtime that's built around simplicity and automation. In fact, we have a lot of large enterprise, large security-sensitive enterprise customers that are standardizing on Cloud Run as their preferred container runtime for their hundreds, if not thousands of applications across their many business units, applications that come in many shapes and sizes. So if you're new to containers, as Gary's mentioned, if you're new to containers, we recommend that you start on Cloud Run. Now, why do we make this recommendation? Why do people choose Cloud Run? So the first reason is Cloud Run is simple to use and simple to secure. So as an example, we had a customer tell us some time ago that they were managing about a dozen security relevant settings on Cloud Run versus 10x that many in a different container runtime. Now, we all know that complexity is the worst enemy of security. So Cloud Run has security built in and on by default. Number two, Cloud Run is fully managed. So there's no infrastructure for you to manage or for you to secure. And so, in fact, Cloud Run runs on what we call Borg, which is our internal container runtime, where Google deploys billions of containers every week. And it's also where we host some of our biggest properties, like Gmail, like YouTube, like Google Search. So Cloud Run is built to the highest security standards that Google has for all of our internal software. And it's important to protect Cloud Run because that's important to protecting all of Google. And so that means, Cloud Run, we have rigorous code reviews for every line of source code. We have multiple layers of sandboxing for all customer workloads. We have zero trust transport security, and we're using strong software supply chain security, and so much more. And last point, Cloud Run is built for developer velocity. So for example, there's a tool, Cloud Run provides tooling for you to deploy directly from source code to production. And that uses, under the hood, Google-provided base images. And so these are base images that are maintained by Google, kept up to date, and patched. We patch them every single week. And if there's an emergency situation, we can patch it in a matter of hours. So if I were to summarize all of this in one sentence, it would be this. If you want to experience that joyful feeling when you're using a simple and elegant product, take a look at Cloud Run. Okay, so let's talk about the design patterns. The first design pattern is for internal-facing websites and web apps. Maybe you have a company directory app or an HR website or an internal news app. You want to make sure that it's only available to your employees, it's internal-facing, and it should stay that way. Okay, so the architecture is actually very simple. Maybe you have your front end running Cloud Run, accessing a database in your VPC, and maybe you have your traffic managed using a load balancer, and you're authorizing your users using identity-aware proxy IAP. So simple and effective architecture. Now, this is actually a great use case and a great fit for Cloud Run because it's not only simple to run it on Cloud Run, it's also very cost effective. So all these internal apps they don't actually get a lot of traffic, especially during off hours, weekends, evenings. And so Cloud Run is able to scale down to 0 when you have no traffic and quickly scale up if you need it. Right, so there's no fixed infrastructure footprint for you to maintain, and you only pay when you're serving traffic. All right, so how do we secure this? Let's talk about ingress or inbound traffic first. So there's a few different components to consider here. First, you have the load balancer. On the load balancer, you can configure a few different security settings. For example, you can configure Cloud Armor to protect against DDoS attacks. And second, we talked about using IAP, Identity Aware Proxy, to authorize your browser users. IAP is actually a pretty cool product. It has a lot of nice features built in. Another thing you can do with IAP is to grant access based on contextual information, like the IP addresses of your end users or their device properties, device attributes. Okay, now when it comes to Cloud Run, there are two main checks to configure to make sure that the traffic, you only allow traffic from your load balancer together with IAP. So first, configure the ingress setting to allow only internal load balancer traffic. And second, configure IAM, Identity Access Management, to allow only IAP's service account. So these two checks, they're a network level check and an identity check. They're fully independent and very complementary. So you can enable one or the other, enable both, and actually a lot of customers enable both together for defense in depth. And if you're new to Cloud Run, these are probably the first two security settings you should learn because they're very basic, very powerful, and actually very applicable to many, many different use cases. All right, let's now talk about egress traffic. So for egress, the main setting to know is that there is a setting in Cloud Run to allow you to send all traffic to a VPC. So a VPC is your private network. That's where you manage it as you like. You can apply custom policies like firewall rules. So a lot of customers want to send all their traffic to a VPC. So that's something you can configure in Cloud Run. And speaking of VPC access, I think there's a great feature that we just launched to public preview that I hope everyone gets a chance to try out. It's called Direct VPC Egress. With Direct VPC Egress, Cloud Run services can now send traffic directly to a VPC without proxying it through a connector. So it's much easier to use, it's faster, much lower latency than before, much higher throughput, and it's lower cost. So we've had a lot of customers try it out, so customers like Care4 Impact, many, many customers try it out and getting great results. I'm a bit biased, but I do think that this is a must-have feature for a lot of customers. One more thing is I do think that, I've said Cloud Run is a really joyful product to use. I think, VPC access was previously not exactly very joyful, but I do think we are bringing the joy back now with this feature, so take a look. All right, the last thing I want to mention on this slide is, we talked about a few different security relevant settings. If you want to enforce specific settings across all of your Cloud Run services in your project, in your folder, in your organization, then take a look at organization policies. So the settings that I talked about earlier, the ingress setting, the IAM setting, the egress setting, they're all subject to org policies. All right, so with that, we'll cover another design pattern. This one is for running internal web services, potentially microservices, services that need to be able to easily communicate back and forth with each other. So there are many different variations of this design pattern. Maybe you have your services running in a mix of different platforms. They're running on Cloud Run, they're running on VMs, they're running on GKE. Maybe they're running on-prem, connected to your VPC using a VPN or interconnect. So aside from that, maybe they're using different network configurations. Maybe they're in the same project sitting on a standalone VPC, or maybe they're distributed across different projects and connected together using a shared VPC. And maybe you have all your traffic going through a load balancer, an internal load balancer, or maybe you're calling Cloud Run services directly using their built-in run.app URL. So many different variations of this design pattern. Now, for all of these variations, the same settings that I mentioned earlier in the previous slide, they still apply. So you have your ingress setting. You can use that setting to restrict access at the network layer. You have your IAM check to restrict access based on caller identity. You have your egress setting to send all traffic to a VPC. And you have org policies to enforce specific settings across all of your services. Now, one thing to pay attention here with this design pattern is for traffic that's going to a Cloud Run service, pay attention to how it's routed. If you are using the ingress setting, a restrictive ingress setting, then make sure that that traffic is using a VPC. Traffic that's going to Cloud Run, it should be using a VPC. So if you're using an internal load balancer, the ILB, then that's always using a VPC, and that's fine. If you're calling the built-in run.app URL directly, then check a few things. If the caller is a Cloud Run service, then the easiest thing for you to do is to just configure it to send all traffic to a VPC, and you're good. If you're using a shared VPC, then we do have a feature in preview right now to support this traffic, as long as the destination Cloud Run service is attached to the same shared VPC. And number 3, if the caller is on-prem, connected using a VPN or interconnect, then configure private Google Access or private Service Connect to resolve your run.app domain to a private IP so that it's routed over the VPC. Okay, so that's it for the design patterns that I want to talk about. They were very basic design patterns, and some of our larger security-sensitive enterprise customers, they build upon these basic patterns to incorporate their more advanced security needs. So one such customer is Goldman Sachs, and with that, I'll pass it over to Shivam from Goldman Sachs to tell us more about how they build an architecture based on Cloud Run and Google Cloud.
Thank you. Hello, everyone. Thank you for joining and being part of the presentation today. Good morning. I'm Shivam Dalal, Vice President at Goldman Sachs, and I'll be talking over how we apply many layers of defense to secure our container apps. Let me talk a bit about Goldman Sachs first. For folks who are not familiar, it's a global financial institution with many lines of different business, which are global banking and markets, asset and wealth management, and platform solutions. Our clients include corporations, other financial institutions, governments, and individuals. Technology is at the core of everything what we do. We have a hybrid cloud environment where we manage our own data centers in private cloud, as well as we use public cloud. So going to my role at Goldman Sachs, I'm part of cloud enablement team, and our mission is to empower engineers to be able to use public cloud securely and effectively. With that, I want to go over the problem statement of what we have as part of a platform team. So we want to ensure our development teams can move fast building applications on GCP without compromising security. In order to do this, we need to send preventive guardrails that ensure compliance behind the scenes without adding overhead. Let's focus on the things which are highlighted over here. Move fast. We want the developer velocity to be as high as possible and the time it takes to deploy an application to be minimal without compromising security. So this is where accidental configuration of resources can lead to some gaps in security. We want to avoid that. And last, preventive guardrails. This is where our role as a platform team comes in the picture, where we set the right layers of defense to protect the resources in GCP. Basically, the gist is that we want our developers from the lines of business to focus on solving the business problems and using the technologies in GCP and not be too worried about how to make your app compliant with all the regulations being imposed in the financial industry. All right, so I mentioned that we want our developers to move fast. So we chose Cloud Run. Basically, we chose Cloud Run because, as Xiaowen mentioned, there are a lot of benefits to it. One, it's serverless, requires no infrastructure maintenance, and then it was a good fit for a lot of our use cases, which I'm going to talk about in the next couple of slides. So the first use case we have is API and microservices. So imagine a team at Goldman Sachs wants to build a containerized microservices hosting a bunch of REST APIs. The goal over here is to allow them to securely deploy a container workload which is accessible from our on-premise network, as well as other workloads within Google Cloud via private network. And then the application should be able to interact with certain Google database offerings like BigQuery, Spanner, and authenticate using Google identities. Let's go over the next use case. So this is basically trigger-based batch processing. So again, a team at Goldman Sachs is using BigQuery for searching and analyzing log data. We want to have them enrich log data before ingesting into BigQuery by adding metadata. So this use case is also perfect for Cloud Run because it's serverless. The application auto-scales on demand because log data can vary. And then again, we want to make this accessible from on-premises. Now that I've talked about the two use cases, I want to go over like basically what do we do as platform team to make sure that we enable Cloud Run as a service. So we use all of these tools available in Google Cloud to aid in setting the preventive guardrails. So with a quick show of hands, how many of you have used more than 2 of these products or services? All right, that's a good number. How many of you have used more than 4? All right, that's a good number. Okay, so I'll just go over quickly like how each of these tools helps us in setting the right preventive guardrails. So starting from the left, IAM grant, this allows who can do what on a resource. Now, what we do is we create custom admin roles for each service we try to onboard on within the firm. So we want to limit the number of permissions that service has basically for the developers. So we don't want to grant basic primitive roles like owner, viewer, editor, or even the predefined roles. Instead, we want to have a set of restrictive permissions which our developers can have access to. And then this can be used by teams themselves as well to control their IAM. The next is IAM deny. This is again a very useful tool which allows you to block explicitly use of over-permissive resources. The next in the slide is VPC service controls. I would highlight, and probably this could be a takeaway for a lot of folks who are not using this. This is like one of a bigger security kind of protecting tool which we use where we allow all of our projects around that we create a bubble which is basically like protected by the perimeter. So VPC service control kind of allows you from protects you from a lot of data exfiltration. So I would strongly recommend you guys to check this out. I think org policy, most of you are familiar, Xiaowen even mentioned, allows you to enforce guardrails around your resource configurations. If you guys hadn't attended yesterday's talk, I think they are also coming up with custom org policies. So that might again be very useful in setting some resource configuration constraints. And then finally, we have tags and policy intelligence, which are also useful in like adding layers of defense. So now that I've spoken about like the different tools which are available at our disposal to use, how do we use this in combination with Cloud Run? So I'll give you a quick second to see the screen. Basically, in this diagram, we have a typical use case of a Cloud Run instance accessing a storage bucket, and someone on premises is trying to invoke the Cloud Run instance. So if you look at the screen, the green paths which are there from top to bottom are what we call as happy paths. So these are paths which are okay to have, and there's no security threats or anything which is possible in there. Basically, an on-premises server is accessing the Cloud Run instance via dedicated interconnect or be it VPN over private network, and then the storage bucket is again sitting inside the same project or could be within a different project in the same organization. However, what's important over here is that the red X's which you see in the diagram are the paths which are, I call unhappy paths. Like you don't want them to ever be like compromised. So starting from the left, if you go from ingress on the left-hand side, Cloud Run being in Google's VPC, access from internet or having access from an unauthorized project could lead to public exposure of private data, or it could lead to your application being compromised in case of stolen credentials. So the way we kind of protect against these threats are, again, as I mentioned, a combination of org policies, IAM, and VPC service control. So the green box you see on the slide is basically the service perimeter. It's kind of, think of it as a bubble around all of the projects you own, or like you can create multiple VPC service controls depending on like your zones or environments, and doesn't allow like projects which are not part of the perimeter. Now, moving to the right-hand side for egress, I want to highlight that, again, Cloud Run being in Google's VPC and has access to the internet, you can exfiltrate data, for example, in case of malicious insider, or let's say you have a compromised code running. You can basically send data to unauthorized Google APIs like Gmail, Google Drive, or even use the storage copy from like service to service copy to copy data over to an unauthorized bucket. All right, so let's dive deep into like a couple of specific org policies which we set for Cloud Run, ingress and egress. So we, as I mentioned, we want to restrict all our traffic to private network. So the run.allowed ingress is set to a value called internal and cloud load balancing. This basically prevents all our developers from creating Cloud Run instance open to the public. The next one is allowed VPC egress. We set this value to all traffic. This makes sure that all the traffic which is routed from Cloud Run container is routed to the serverless access connector. And as Xiaowen mentioned, this was basically a lot of operational overhead for us to manage serverless access connector, and with direct VPC egress now being in preview, we'll be happy to start using that. This is another org policy which is preventing unauthenticated access. So in Google, you can have IAM binding, which says allow all users to access basically my Cloud Run. This is something we want to avoid in case of accidental configuration or some malicious intent. So the way we do it is set an org policy which says only allow policy member domains set to our organization. So this prevents the developers from setting that. Finally, I wanted to go over a couple of Cloud Run patterns which might be useful for folks over here, which I think is one, how do you access a Cloud Run from on-premises? And the second one is, how do you access Google services and other APIs from your Cloud Run container? So in the diagram over here, basically, I wanted to highlight key components, which are interconnect and the private service connect endpoint, which is in the transit VPC. Traffic flows from on-premises compute to the Cloud Run instance via those. And key thing to keep in mind is the private service connect endpoint in transit VPC is of target type VPC-SC. This ensures that your traffic only goes to the restricted Google APIs, which is again is protected by the VPC service controls. So those are the two important things. And then run.app URL is part of the restricted .googleapis.com. So you can pretty much hit any Cloud Run service across multiple projects as long as they all belong to the same perimeter. All right. The next pattern is how do you access other Google services and Cloud Run from within a Cloud Run instance. So as I mentioned previously in the org policy slide, we require that Cloud Run traffic all is routed to the egress connector. So that's the number 2 over there. And then basically we make sure that the subnet on which the connector is has private Google access enabled. And again, just that configuration itself might not be secure enough. What you need to make sure is that you have the right DNS setting to configure that all Google APIs traffic is routed to restricted.google APIs. This again ensures that the traffic can only flow to all the services which are protected by VPC-SC. And what we do is any new service we add, like for example Cloud Run, we add it to the restricted APIs list in the VPC service controls. And this way the access from the subnet to unauthorized Google APIs or to unauthorized project is prevented. With that, I'd like to conclude my talk and hand it over back to Xiaowen. Thank you.
All right, thank you, Shivam. So Goldman Sachs has been a great customer, and it's been super fun to work together to meet their advanced needs. Okay, so I'll just take a couple minutes here at the very end to summarize some of the features that we talked about. So please try out direct VPC egress that lets you easily connect to a VPC. It's easier, faster, and costs less. Take a look at ingress and egress settings that lets you restrict and manage the traffic to and from your Cloud Run service. Take a look at IAM, the IAM setting that lets you add another layer of defense, use org policies to enforce specific settings. Number 5, use VPC service controls. You know, Shivam really talked about VPC service controls as being a very important part of their architecture to protect against data exfiltration. Number 6, take a look at using Google maintained base images. So you can rely on Google to patch them, keep them up to date, and especially in the case of a security vulnerability. And number 7, use binary authorization to make sure that only your approved images can be run in production. Now, we talked about a lot of features, a lot of great features today. I just want to mention that we didn't have time to cover everything. And in fact, there's one feature that I want to mention that we didn't get to cover, but I think is super exciting. So at Cloud Next this time, we are announcing that Cloud Run now supports, in public preview, sidecar support. So now you can run a sidecar container next to your main container to add additional functionality. So, and this is super important for security use cases. For example, you can run an Envoy proxy as a sidecar container, or you can run OPA, Open Policy Agent, as a sidecar container to enforce your custom authorization policies. And there's a talk at Cloud Next that's dedicated to that feature on Cloud Run, so take a look at that. Okay. Sorry, I keep going in the wrong direction. All right, and finally, I'll leave you with a few resources. If you are new, take a look at our quick starts. If you want details, take a look at our security guide and our private networking guide. And if you are ready to go, ready to automate, take a look at our Terraform blueprints. So with that, thank you all for being a great audience. If you're new to Cloud Run, I hope you get a chance to try it out and experience the joy for yourself.